How do you get a utility curve? Let's have some fun putting together our own utility curve. Let's say we're talking about the possibility of either losing $5,000 or gaining $10,000. When we're over here, we're talking about you getting an extra $10,000, and when we're over here, we're talking about you losing $5,000. To calculate the utility for each amount of money, we create this decision tree, where you're choosing between either taking a gamble, which is risky, or a gift, which is certain. The gift may be positive or negative, but the point is, it's always a choice between an uncertain outcome and a certain outcome. The probability of winning the gamble is P. Next, we change the value of the gift and work out what value of P for you makes the gamble worth the same as the gift. So we'll start at this end here. So we're talking about losing $5,000. What value of P makes losing $5,000, which is your gift, the same as taking the gamble? Well, the gamble involves getting $10,000 or losing $5,000. The gift, in this case, is equal to the worst outcome. To make the gamble also give the worst outcome, we would need to set the probability of losing $5,000 to be 1. So P would have to be 0. Therefore, the utility is 100 times 0, which is 0. So I'm going to draw a red cross here. So now, let's assume that the gift is $10,000. If you had a choice between getting $10,000 or taking this gamble, what probability would make the two choices equivalent for you? Well, the probability is either getting $10,000 or losing $5,000. So obviously, you'd have to have a probability of 1 to make them the same. The P would have to be 1, so therefore the utility would be 100 times P, which gives 100. So we insert this value in the graph. Now it starts to get complicated. Let's make it so the gift is nothing, or $0. I'm not going to give you money. I'm not going to take any away. But the thing is, there's this gamble on offer. So we want to know the value of P, which makes it so that the gamble is equivalent to getting nothing. Since the gift is larger than $5,000 and smaller than $10,000, the value of P must be larger than 0 and smaller than 1. So let's have a quick show of hands. Let's say P was a half. I want to see how many people would take the gamble. If P is 1/2, then the EMV of the gamble is half of $10,000, which is $5,000, minus half of $5,000, which is $2,500. So the EMV is $2,500. So if P equals half, then on average the gamble gives you $2,500, right? So who wants to take the gamble? Who wants to take the gift? So that was about the same number of people on each side. So let's say that P in this case equals 0.5. And 100 times 0.5 equals 50. Now we're going to look at this point over here, where the gift is $5,000. Let's think about it. When the gift was $0, the class chose a value for P that on average made the gamble worth $2,500. When the gift is $5,000, you will want better odds than you were willing to accept when the gift was $0, so you will want a higher P. So let's try a higher P. Let's try P equals 0.8. That times $10,000 gives us $8,000. 1 minus P gives us 0.2 times $5,000 gives us $1,000. So the EMV in this case would be $7,000. So your choices are 80% chance of winning $10,000 or 20% chance of losing $5,000, or I just give you $5,000. Who wants to take the gamble? On average, you'll be better off, but not always. Who wants to just get the $5,000? Okay, most people seem to just want to get the $5,000. So I'm going to have to increase P to make the gamble more attractive. Let's say we put P as 0.9. So 0.9 times 10,000 gives 9,000. 1 minus 0.9, that's 0.1, times 5,000 gives you $500. So the EMV of the gamble is 8,500. But once again, you've got a 10% chance of losing $5,000. Who would want $5,000 and who would want to take the gamble? Firstly, who wants the gamble? Secondly, who wants to take the $5,000? Less people have their hands up this time. So I'm going to split the difference and say people would want 0.85. Now we can connect all the dots on our graph and we get ourselves a utility curve. So that's where the utility curve comes from. In this case, we tried to take the average of the class. In practice, different people will have different curves.